Welcome to my 9th video for my game design project where we're making a action RPG Zelda-like game in Unity. We left off with blobs finally having the ability to attack. After some long code for the AI here, we've got enemies that can attack us. Well, a single enemy type. And what we're going to try to do in this video is add a ranged enemy that actually has a different type of animations than the blob does, just to kind of take a look at a different way that we could handle things if we wanted to have like directional animations for an enemy. And so let's get this started. To make this a little bit easier, I've already created custom packages for this so we don't have to rig up all the animation ourselves. So I've got a top-down 2D skeleton package, and we're going to import that. It brings in some animations and the sprite sheet and a prefab with just the basic setup, no actual scripting on it. So let's import this. The one thing I did want to do is, from a naming consistency standpoint, I do want to bring these skeleton animations into the enemy folder. So I'm just going to drag that up there. Unity should automatically update all the dependencies, so it shouldn't really break anything with regards to the skeleton. And then also I'm going to import another custom package, and this is a top-down pixel projectiles. So what this is just kind of like 6 different ranged attacks that you could use for monsters. We've got 4 different elemental things, a dark-looking bolt, and a bone that spins. And I've already animated all of these and cut up the sprite sheet, so when we import this, we'll be able to use those as well. Those go into the enemy folder. This already imported into the enemy subfolder of animations, and then textures, it added those all into enemy. So it all kind of fits nicely with the rest of our project. And so let's kind of take a look at the skeleton prefab that we've got going. We can just drop them into the world somewhere. Move the animation to the side. Let's see how he's set up, just so we can get an idea. So the skeleton actually has a bunch of different ones. We already have a ton of things set up for the skeleton. And so the skeleton is able to have these directional animations for it to do different things. Now, let's further look at the animator and see how that's set up. So the skeleton, here's all of our different pieces of the skeleton. He's using blend trees, so kind of share some properties with the players for that. And our triggers, we've got some floats, we've got horizontal, vertical speed, so much like how we handle the player. Is hurt as a boolean, exactly how we're handling the blob. Attack trigger and a death trigger, because the skeleton now has a death animation. And so most of this is already compatible with the enemy script. Is hurt and attack are triggers that are both used by it. The blob itself actually had a much simpler animation tree. As you can see, it just has an attack and is hurt. Otherwise, it just sits in the idle state most of the time. Which kind of gets into that whole thing I said, legs are your enemy, and this is partly why. And so that's how the skeleton's set up. One thing to note about the animations, though, is I did not actually place any events on there. So we're going to write the code for this where the skeleton, the animation doesn't actually send the code events. We're going to handle it all through code and timers ourselves. The projectiles, like the firebolt, for instance. Oh, it's hiding behind a tree right now. Or hiding behind the camera, rather. So the firebolt looks like that, and it animates, and it actually has a trigger for, why is it the wrong animator? So here's its setup. It's got a firebolt, it's got a trigger called impact, so it's much like the player fireball, and it goes into a little death animation for it. The bone itself doesn't actually have that. It doesn't have an impact trigger, and so it's not going to. We just didn't have frames for it to like disappear. So the bone doesn't have an impact trigger, and so those are the projectiles that we can use. The Firebolt and some of the ones like it are set up in an interesting thing. The image is actually the child here, and that's because the sprite sheet actually had this facing in a different direction. So those are our tools, and let's, I guess, begin kind of getting the skeleton ready for being an enemy. So if we open up the skeleton inside of the prefab editor, we can see our wonderful skeleton already has the animations in the sprite renderer set up, but we don't have the rest of the skeleton, so it can actually be a true enemy. First up, let's tag it. It needs to be tagged as an enemy so that we can actually hit it and damage it. Next up, we're going to need to put the physics stuff on the skeleton. So I'm going to give it a component, physics 2D, and a circle collider. We're going to tweak that size in a second. We're going to also add a physics 2D, rigid body 2D, and then we'll tweak those settings. So let's start with the circle collider. I don't really feel like assigning a bouncing material to it, so I'm just going to leave that just to be the default. However, I do think that the radius needs to be smaller. So 0.5 looks reasonably good. And we're going to want to drop it to like negative 0.15 so that kind of is the center of the skeleton. We could make this smaller if we wanted to, maybe drop this down to negative 0.25, and then that becomes kind of the feet of the skeleton. Also the hitbox for our attacks. We're still using a singular collider for both physics movement as well as taking damage. That could be something that would be worth exploring in future projects, but for now we're going to try to keep it somewhat simple. This is not going to be a trigger, so leave that unchecked. Rigid body 2D. Right now, not many changes here. We do want to make sure it's dynamic. Let's change the mass. So let's think. Well, what was the blob's mass, I guess, is my question. The blob is sitting at a mass of 10. So the blob, pretty high mass. Maybe the skeleton should be a little bit higher. Let's go 15. So the skeleton actually gets knocked back a little less than the blob. The blob has a linear drag of 3. Skeleton, let's bump it up to like 4. Let's just see how that plays out. Angular drag is fine. Gravity scale should probably be 0. And we want to freeze the Z rotation because we don't want the skeleton to start like just spinning. That would look weird. And so that looks good for all of our settings here. Now we need to start working on a script for the skeleton. So I can back out of my prefab editor, and let's go to enemy scripts, the subfolder here, and I'm going to create a new C# script called skeleton. Then we're going to open it up. So the skeleton script is going to share some similarities with the blob script in the sense that like it's going to want to inherit from the parent class of enemy. So that's what we're going to do. Let's go over to the skeleton and let's make it inherit from enemy. So now it's loading in all those properties from enemy. It's mad because I think we have to implement this attack method. I'm going to take out that system throw, and I'm going to move it to move down here. All right, so now we've made it. We've satisfied an update. I think it needs to also say that it was overridden, if I recall. Yeah, public override. I think it gets mad if you don't put public because I think it defaults to protected. Oh, yeah. And so it's mad that the access visibility is not the same, so we need to make sure it's public. Cool. Delete the start method so it doesn't override the enemy's start method, because remember we ran into that last time where this was actually replacing the one that we had written in enemy. So if we recall, the first thing we need to do in update, much like we did with the blob, is call the enemies update one. So we're going to grab that and we're going to do the same thing here. So now it's going to do all the standard stuff. It's going to run all the AI behaviors, and at that point, it's basically a full-on, full-fledged enemy. The only thing is like we were handling the attack uniquely in the child class. The only thing that the child class, as you can see, is responsible for is our attack logic, and I guess technically moving too. So let's grab the move method here. And probably maybe we should take the attack method as well, just to finish it out. So kind of looks good. Let's see about this. If I recall, on our enemy's attack though, it does its attack if it's not stunned. I guess all that's probably fine, because on our blob we're still preventing it from attacking based on its cooldown. So now we need to start doing the code unique to the skeleton here, and so that's going to be our attacking logic. Skeleton does prefer ranged combat. So let's start setting up the attacking logic for this. The skeleton's not going to have a melee attack, but it will still try to do a ranged attack, even in melee range. Because if the player is within the range for a ranged attack, the skeleton's still going to try to shoot at him. If you wanted to define a separate piece of logic here, you could. You could actually take similar to what the blob is doing here, and take this so that the skeleton could do a melee attack that could be different from its ranged attack. But I think if we got into that, that may make this video a bit too long. So let's look at the ranged attack for the skeleton. So in order for it to want to do an attack, let's think about the conditions that need to be true. There needs to be a target, so target is not equal to null, and the skeleton is not stunned, and it is not currently already attacking, and the attack cooldown ticker is less than or equal to 0, so basically the monster is ready to attack. Now you might be wondering, well, what about range? We're going to check the range inside of here, because I can't grab the range yet, because if the target's null, I might have a null pointer exception. So I have to wait until I get into this method. And plus, there's no reason to be checking range to the player if you're stunned or if you're not ready to attack, so we can save little CPU cycles there. So we're only checking the range if the skeleton is actually able to perform an attack. So we'll get the distance, vector2.distance, from the target.position to the skeleton's transform.position. Now, we could take a look at how we did this in the blob. And if you look, maybe realistically we should think about doing this offset stuff, because we really should be calculating the distance from the center of the colliders rather than purely the center of the object. So I am going to copy this, and I'm going to take that distance calculation and use it inside of here. This is really simple, but I feel like we probably should use a more complex computation. And I'm leaving that commented just, as a reminder of so I'll leave that comment there, that it uses the center of the object, not the center of the collider, which could have some unintended behaviors. Alright, so we've got a distance here. Maybe we could steal some more of this. Oh, I'm probably just going to write that myself, I guess. Let's just take that. So we're going to take this code from the blob. If the target is in range, start a ranged attack. So if distance is less than ranged attack range, notice that we can still see the variables of the parent class. And we're not actually going to be handling our animation is not going to be calling this stuff, because in the blob, to jump over to Unity real quick. If we recall, blah, 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 blah. The blob actually does, during its attack animation, use animation events to signal the attack method and to signal that it's done attacking. But I did mention that we're not going to set the skeleton up like that. The skeleton's attack animation won't. And that's partly because I'm using a blend tree. And if you recall from the player, the blend tree could actually trigger 2 calls to the method at the same time. So blend trees and animation events don't always play the nicest together. So that's actually why I'm avoiding it in this specific case. Additionally, it's good just to see how to do it in different ways so that you don't have to rely on the animator to call these. All right, so we're going to take that out. The animator is not going to be calling the attack method. So that means we will need to establish a timer to do this. However, the skeleton does have an attack animation, so we should play the attack animation, set it to be true that we are attacking, and then we need to make a few variables for our skeleton. So up here. So the skeleton needs a variable. I'm actually wanting to do 2 of these. So we have a public variable. I'm trying to decide if I really want to make that public. Ranged. We'll make it private for now, because that really shouldn't be something that that somebody who's planting the enemies inside the world should really, because this is linked to the animation, so we don't really want this publicly exposed. Ranged attack delay. This is how long this is how long of a pause from when the skeleton starts its attack animation till when it's going to actually throw its projectile. So basically the skeleton's going to rear up, giving the player a visual cue that it's about to launch an attack, and you have about a little under half a second to hit the skeleton to stun it, which will break it out of its attack animation. And then this time, I actually kind of calculated it, a little bit of trial and error, but I was basing that off of its animation of how long this actually takes. Because the skeleton raises its arm up, and it's really kind of hard to see, but it raises its arm up here, and then it actually like flings its hand here. So you can kind of see that if this is on a 60 frames per second, it unleashes it about actually at 50% of the way through it. So maybe we could change that. If I recall, when I was originally testing it, I found that the number 3/8 worked a little bit better. But we can try bumping this up to 5, since it looks like in the true animation it should be coming out then. So then this is ranged attack delay ticker. And that's going to be the actual timer that ticks down until it launches its attack. So we're going to go into here and set if the target is in range, start the range attack is attacking is true, and ranged attack delay ticker is set equal to the range attack delay. So the skeleton will begin this countdown for when it's going to start. And then exiting this, right outside this if for the ranged attack, we will decrease the ticker. So if ranged attack delay ticker is greater than 0, then we are going to subtract our time from it. Time dot ranged attack delay ticker minus equal times dot delta time. And if this happens to go to 0 at this point, we need to have the skeleton to begin its attack. So if ranged attack delay ticker reaches 0 at this point, we are going to run the attack method. So if the timer's up, it's time to spawn the projectile and let the skeleton fling its thing. I believe also we might want to consider, well, I think that's actually set up inside of enemy. When it makes its ranged attack, it receives the attack cooldown ticker penalty, so it will have to wait until it can do something again. And actually, it does get set back to is attacking is true, so it remains in this attacking state for a while. Let's see if the ticker on that. Let's check our attack cooldowns. It does pull us out of attacking when that cooldown is up as well. So the skeleton is going to stay in the attacking state until that cooldown is ready. Good to know. So looking at the skeleton's attack method now, we should probably change this. So it should attack. We should probably just, on the safe side, if it's not stunned, then it commits a ranged attack. And I know that inside of the script it is going to set it back to is attacking is true. Could be worth considering if we want to set it back to is attacking false. Alright, so we could override it if we wanted to. Alright, so that's going to get our skeleton throwing some weapons at us. There's one other thing I want to do. Right after we call update, base.update, if the skeleton is attacking, I want the skeleton to actually just stop moving. So move modifier is going to be set multiply equal 0. We're gonna make it 0. So no matter what it was doing, it will stop. If the skeleton is aiming or it's recovering from its ranged attack, it's not allowed to move. And so that's what that does. So the skeleton stops moving, it rears its arm up, and then it throws a projectile. And if it is still in the is attacking state, it can't move until that wears off. So, and it will because of the way that we have this set up. And so it looks like that should be good to go. The only thing that we don't have ready is all of its animation kind of set in depth. So let's take our skeleton script and attach it to our skeleton prefab. So maybe double click your prefab of the skeleton. Unity's got to do its updates. And we want to take the skeleton script and attach it to the skeleton. Now we probably should go through these options here, and there's a few more things we do need to set up on the skeleton. So the name, it's going to be called skeleton. Maybe skeleton archer. Technically it's a ranged unit. Health. We don't need its gizmos. Move speed. I feel like the skeleton should be slower, so let's go like 1.5. Patrol speed modifier. It's already pretty slow, so maybe just go 0.8 so it doesn't slow down too much. We'll fill this in uniquely on the enemy. Its health. Let's go with 40, so it's slightly more sturdy than a slime. Death effect. We could still slap in the poof. I think that's under effects. Smoke puff. It does prefer ranged attacks. Melee attack range, well, let's just drop that to 0, because I don't really want the skeleton to be doing any melee attacks. We can leave that. The melee attack cooldown, that's fine. Range attack range. Let's go with 3 for now, and let's see how that works. We're going to need to make a projectile for it. And the range attack cooldown, that's going to be pretty fast. It's going to shoot like a machine gun. Let's go with 2.5. So 2.5 seconds in between its attacks. Default state is idle and aggro radius. We kind of just have to ask ourselves, do we want the skeleton to be more aware of us than the slime? And I think skeletons are probably smarter than slimes. So I'm going to bump that up to 8. So really the main thing we're missing is this range attack projectile. And that's actually going to get us into some trouble because we don't have a projectile yet. We could just put the bone in there, and what you're going to see happen is it's just going to appear and do nothing. But on the plus side, at least the skeleton has a projectile. So we hit run, and our skeleton's there. I'm getting harassed by a slime here. And unfortunately, though, if we don't have its animation set up, it is spawning the bone appropriately. And you can see that it stands still after it attacks. Now, if you wanted to move after it attacks, if we were to take out and re-enable this line, the inside of the attack method is attacking is equal to false. If we re-enable that, the skeleton will begin to walk after it attacks. I'm going to move this slime, because that slime is interfering with my ability to do stuff. Alright, so skeleton now. And you know, we can turn on its gizmos, or we can just watch its gizmos. So you can see it has a way bigger aggro radius than the slimes. You can see it trying to get into the player to get into range, and once I'm in range, throws the bone. Throws the bone and begins walking. So you can kind of choose how you want it to behave. If you want it to stop as it's recovering, but I feel fine how it is right now. So we need to get its animations working and then fix the projectile. So let's go get the animations working, and then I think we'll probably branch this off into a second video for its projectile and its death animation. So let's pull our code back up for the skeleton. And we need to start configuring its animation. So that's going to be handled inside a fixed update. We're going to handle its animation stuff specific to the skeleton. So first up is, if the skeleton is in the idle state, what should it be facing? Well, we can actually set that. So let's add another variable that's unique to the skeleton. We'll make this one public facing. Vector2 called default facing equals new vector2, and 0, -1. We'll put a comment here. Tooltip. So that recommends facing down. So let's start setting up the animation here for the skeleton so that we can make it look good. So if the state, and notice again, we have access to all these variables because they're coming from the inherited parent. So if the state is idle states, and we're basically close to where we want to be, vector2.distance to the target location to the transform position. If that is less than or equal to, let's go with that, 0.1. So basically meaning we are where we want to be. If it's not really moving, then we're going to say animator dot set float. horizontal default facing dot x, and that's going to set 0, so or it could be left or right depending on which way we want the skeleton to face. And then we'll set the vertical to default facing dot y. And so if the skeleton is not moving, just face in that default direction. Otherwise, we are going to actually set it animator dot set float horizontal. We're going to base it off of where it wants to go. So target location dot x minus its current position. Transform dot position position dot x. So if it wants to go to a position that's to the left of it, it's going to be facing left. And we're going to do the same thing for the vertical. So if where it wants to go is below it, then it's setting this value to something being below it. And then the blend tree will handle the correct way that it should be facing. It'll consider which one's a more powerful direction. And this one's a little bit hacky. I'm going to set the speed to the move modifier. Because if the move modifier is 0, then it's going to be standing still. Perhaps I should also consider if it's stunned, it should probably be 0 too. But it would be in the hurt state if it's stunned. So the attacking animation, if target is not equal to null, we want it to be facing whatever it's thinking about attacking. So instead, we're going to change its horizontal thing from being based off of a target location to purely the target's location, target.position. And we're still going to use transform position. And so for vertical, we're going to just do Y's. So just adding some comments here. All right, so if we have a target, got that. And then lastly, let's just get the speed. So if vector2 dot distance to the target location, comma, transform dot position, if that distance is less than or equal to, we did 0.1 on the other one, so we'll do 0.1 here. Then we're going to set the speed to 0, else speed will be move modifier. Now, could I take this out and have it work? Probably. So we'll save this. This should update the animation for the skeleton to actually kind of do what it needs to do for facing things. So if you need to pause the video to grab that, I would consider doing so. So let's test this. And if we get a successful animation of the skeleton, we're going to come back to finish this up and do the projectile and then do the skeleton's death animation in the remaining video. All right, so our skeleton does seem to be, ooh, got a very angry slide. The skeleton is following me around. It is correctly doing its attack animation facing me. And it does appear to be working pretty well. And the only thing that we could possibly do maybe is slow down those walk animations. So we could always pull up the skeleton and its animator. the blend walk is lower the speed a little bit. And that lowers the entire animation speed for those animations. So I dropped it to 0.8. And that'll maybe sync the movement a little bit better. So you can continue to mess with that number. I think maybe like 0.7 or 0.6 might look good. So we're going to end this video here. We still got to kind of set up these projectiles, and then we've got to work on the skeleton's death animation. And then we will successfully have added another type of enemy with a very different style of animation to this game. So make sure to save your work and join me for the last main video of this series, where we have the projectile actually working.